Welcome to Ask and Learn.
So here we have three situations, and we want to see which one of those causes the biggest change in momentum for the baseball. So the baseball is at the same speed, whether it is leaving the hand of the thrower or when someone's catching the ball. So for the first case, obviously for all of those cases, the ball also has the same mass. So for the first case, we can do the changing momentum, which is the mass of the ball times the change in the velocity of the ball. So in this case, is final minus initial. The final velocity is going to be 0. And the initial velocity is going to be v1. We also have to keep in mind that all of these velocities are vectorial, and momentum is also a vector. So in this case, the changing momentum, the magnitude of the changing momentum in this case is going to be m minus, because of negative over here, minus m times v1. So it's going to be equal to the velocity of the ball times the mass of the ball in the opposite direction of the initial speed. That's going to be the change of momentum in the first case. The second case is the same thing, m times delta v. And here delta v, final velocity is going to be v2 minus initial velocity, that is 0. So we get that the change in momentum is going to be m times v2. And then in the third case, first it's also m times delta v, and then we're going to have m times, so here we have something interesting. The final velocity v4 minus v3. If we were to just subtract one from the other, we would get 0 over here. But since this is a vectorial subtraction, we have to take account into the direction of the throw. So v4, if we say that in this side it's pointing to the negative side, we're going to say that v4 is equal to minus v3. So we would get that the change in momentum would be minus v3 minus v3, which would be equal to 2 times m times v3, and all of that negative. We are only concerned about the magnitude of the change. We don't really care too much about the direction of the change of momentum in this case. So the magnitude of the change in momentum in this one, if we call the magnitude v, in the case A, is going to be mv, case B, mv, and then case C, since it's twice, it's 2 times mv. Oh, sorry, this is case C. So we see that in case C, catching the ball and then throwing it back in the opposite direction is the one that changes the momentum of the ball the most.